Hi, good morning, everybody, and happy Sunday. Welcome to the first or third or second of the final three presentations that we'll see as part of the Info 550 class. My presentation is on managerial decision support systems. Let's go ahead and get going. So first, we'll define a decision support system, what different types of DSS systems exist, different classifications. We'll go into how they support organizations. We'll do a quick dive into practical application, and then we'll leave in closing with a summary and leading questions into the forums. Defining DSS. So what is a managerial decision support system? And then a quick definition. A DSS is an information system that supports business or organizational decision-making activities. It's a very broad definition. And because of the scope of the definition of a DSS, I've actually left off the managerial aspect of this for the majority of this presentation. We will focus on models within DSS and how they support managerial decisions within a business organization. But the general term or the general definition of DSS, I think, leaves it really for supporting decisions outside of a pure business context. So really we'll just focus on DSS. There's some core features that are associated with the DSS. While the definition is very broad, there's typical features that are normally addressed through a DSS. And that can be that a DSS would handle less structured problems. So a very structured problem might be something that a very simple report could answer, such as how many customers did not receive an order yesterday or have orders pending. The less structured problems might be something like, how do I improve customer satisfaction in my organization, or what is my optimal pricing mix for a given product? How do I price it across markets? Which kind of feeds into models or analytic techniques that are used as part of a DSS. DSS are usually, or should be, easy to use, intuitive for users. Not every user is going to be an engineer or data scientist. So they need to be relatively intuitive for the users that are using them. Flexible and adaptable. They need to be able to support a lot of changes. If we're talking about unstructured problems, these systems need to be able to support the decision-making process as it changes and as inputs change as well. Some of the core components, there's really three, and then they're encompassed by an overall user interface. Which would be the user interface, knowledge base. So what are the inputs that make the DSS system work? And then the actual model or the brain behind the decision-making process. And the model really comes into play when we start talking about knowledge-based or model-based, model-driven systems. And we'll touch on those shortly. Just a quick point in the evolution in terminology. We're talking about decision support systems, and I thought it would be appropriate to include a Google trend graph of terms that have been used in Google since 2004. And we really see that around 2004, as far back as Google Trends go, the searching for decision support systems starts to drop off, and the increase in use in business analytics and predictive analytics really takes off. It doesn't change the theoretical aspects behind decision support systems. I think the context behind DSS still holds true today. It just might be called by a different name. It really takes on a lot of different forms within the business place or just any organization. And just a quick disclaimer, I'm not going to go through a lot of the history behind DSS. I think in summation, ever since computing systems or automated systems have come out, researchers and theorists have come out with ways and classification systems to really help support decision-making process, taking advantage of technological solutions that are available. And we really see that as AI starts to take off. There's even a bigger push towards automating as many decisions as possible. Some of the unstructured support that DSS provides, still something that's going to be very difficult for AI to do. It's something where human intervention is really needed. But as AI develops, it will increase the use of DSS. Different types of DSS. So there's five main types of DSS, and that would be communication driven, document driven, data driven, model driven, and knowledge driven. There's another context or piece that I want to add in here, which is going from passive to active decision recommendations. If we look at something like Google Documents, which would be classified as a more communications driven DSS, it's a very passive version of DSS or type of DSS. It really helps to facilitate the overall process behind decisions. It increases the collaborative abilities between different teams across different regions, but it doesn't actually provide recommendations. It just supports the overall process passively. And then we get into more of the active decision recommendation piece. When we start talking about knowledge-driven DSS, we're really talking about something like a good example would be Watson for clinical decision support systems, where it would take all of the inputs for a given patient that are available. It would take that information, and based on models that have been developed, the system would then provide an output, which might be 1 to 5 different diagnoses with varying degrees of probability. And it would put that in front of a clinician or physician to allow them to make a decision at that point on how to proceed with a diagnosis. And then anywhere in between, we start talking about what-if scenarios for data-driven DSS or model-driven DSS. It really puts the data in the hand of a user and allows them to interact with the system and go through an iterative process determining what would happen if variables were changed and what would that do to the outcome. We're really going to focus more somewhere in the middle, which is more in the cooperative area, data-driven and model-driven, which are used very frequently in the workplace. How DSS supports organizations. So a classical structure, representation of information systems throughout an organization is something that you'll see below, which comes up anytime DSS is searched on. It breaks out the different IS or information systems across an organization from an executive level through a transactional processing system and how they're used throughout the varying levels. So an EIS or executive information system would be used at the executive level. DSS would be used for directors, senior managers, management information system managers, and the transactional processing systems, like processing an order through ERP. An ERP system, for example, would be something that, on the analyst level. And you can see the decision support systems in the classical context is usually targeted towards directors and senior managers. But I think if we look at decision support systems as a system in place to support a decision, there's problems throughout an organization and just varying degrees of complexity for how those problems can be aided towards a decision. So I'd actually make the argument that a DSS covers all aspects within an organization with varying degrees of complexity. So we talk about the executive level, we start talking about executive scorecards or executive dashboards, something that would really help an executive pinpoint an area within the organization that they view should be of strategic importance. For example, if employee engagement is very low, and that's represented within the scorecard, in the context of the overall organization, that might be an area of biggest risk and allows an executive to focus their resources on areas that have the biggest impact. Directors, senior managers is really when we start talking about analytic what-if scenarios. So I've mentioned the pricing optimization previously, and we'll talk about that in a deep dive. It's really helping to facilitate a decision on how to optimally price a product across different regions in order to extract the most profit from that product. A lot of what-if scenarios go into the development of that pricing. Managers and analysts would use a lot of structured data from data warehouses, so analytical and transactional type data. Managers might use that information to help allocate resources on their teams based on how they're seeing things play out. And analysts might use the structured data from a data warehouse for transactional reports to let them know how many customers didn't have orders placed. Really more structured problems with structured answers. We'll do a quick deep dive here into a practical application. And this is where it starts getting really interesting from my perspective and something that's applicable in my industry. So when we talk about a model-driven DSS, and we'll say it at the executive level, it could be the director, senior manager level. The question that's going to come up when a new drug comes out is how should a new drug be priced in order to optimize the overall profits across the globe? There's a lot of inputs associated to this. Again, it's at a global level. Every region is going to have a different price point. The clinical efficacy of a given drug, either whether it's a novel drug and especially against competition, is going to come into play in how to price that product. The size of the overall patient population and the disbursement of the patient population across different regions is going to play a very big role. Channel distribution. So what are the appropriate channels to use and what is the pricing mix going to be for those channels is going to be a very key input as well. And the list goes on. Essentially, these all come into play, all of these different data inputs. And what happens is folks put together very complex predictive models based on essentially global and regional levels and all of those different inputs. There's a lot of what-if scenarios that play back and forth as folks look to optimize the pricing for a given region. And really, it helps them set overall price points by region as a starting point. There's not one global price. It's usually priced by region. So these decision models or predictive models really help to optimize price by region. So for example, you might see a US list price at $100, Canada's list price at $30, EU's at $35, and emerging market at $15. This would be used as more of a starting point, as an output of that what if, as an output of those what if scenarios. And the next step would really be taking that down another level even further and optimizing pricing within a given region or channel. So within the US, there are many different channels that a drug could go through from a commercial or government perspective, and that's going to have an impact on the price across the board. So these global pricing models are used as a feed into a regional pricing model. So in closing, decision support systems are increasingly woven into our day-to-day. From Google, document sharing, reporting, analytics, they're really pervasive across the board. And they really help to support simple to very complex decision making. I view DSS as a very broad methodology. It can be used to help answer very simple questions all the way to the very complex and unstructured questions. They're becoming increasingly powerful through the use of technology, improved technology, ubiquity of devices and information available, and through advanced models as they continue to be developed. They're also used across almost every domain. That's why we dropped the M from this. We start to take a look at some of the other examples. Decision support systems could be used for precision agriculture, how to best water a given part of the land, when to use fertilizer, identifying terrorist threats, as well as clinical decisions. We talked about the clinical decision support systems previously. Watson would be a very good example of this. And a few closing questions just to leave you with. What is the most interesting or unique domain you could see DSS being applied to, or is this currently being applied to? How do you interact with decision support systems in your organization? And how do you see the development of AI enhancing decision support systems in general? A few resources here. I'll jump back. Closing questions. Thank you very much for your time. Hope you guys enjoyed this, and I look forward to interacting with everybody on the forums. Thank you.